We are all living through this incredible AI gold rush, right? I mean, ChatGPT, Gemini, they're everywhere. But what if I told you that the very foundation of this whole revolution, the large language model, is already hitting a dead end? So let's get into it. In this explainer, we're going to track this massive shift happening in AI, moving from the models we know, the ones that just predict language, to a whole new generation of systems that might actually understand reality.
Wow. I mean, that is a bombshell of a statement. And it's not from just anyone. It's from Yann LeCun, one of the literal godfathers of modern AI. Think about what he's saying. He's arguing that these systems we think are the future, they're actually a dead end. That one claim right there, it sets up the entire conflict, the central question we're exploring today. Is the path we're on leading to real intelligence, or are we about to see a huge, radical course correction?
Okay, but first, let's give credit where credit is due. The current age of AI, it is defined by just breathtaking fluency. You've seen it. Models like GPT-4 can write code, they can draft legal contracts, they can even write poetry that feels genuinely moving. They are absolute masters of language, and how fast they've risen has been nothing short of explosive.
So where did this all start? Well, the big bang for this whole era was a paper back in 2017 called Attention is All You Need. It introduced what's called the transformer architecture. And from that moment on, the strategy for making AI smarter was, brutally simple. Just get bigger. That's it. And that one idea kicked off what we now call the scaling wars, this massive industry-wide race to build the biggest models imaginable.
And just look at this graph. The climb is it's vertical. It's insane. We went from GPT-2's 1.5 billion parameters to GPT-4's estimated 1.8 times trillion. That's not a typo, trillion. This absolutely colossal increase in scale is exactly why we suddenly got systems that could pass the bar exam. The entire bet was simple. Bigger always means smarter. But as it turns out, there's a ceiling to that idea.
And that right there brings us to the core problem. Because for all of their incredible fluency, these models have some really fundamental flaws. They are hitting what people are calling the scaling wall, a point where just throwing more data and more processing power at them, well, it isn't fixing the deepest issues. So to really get why, we can actually borrow an idea from the psychologist Daniel Kahneman. You see, current LLMs operate a lot like our system one thinking. It's that fast, automatic, intuitive part of our brain. It's all based on pattern matching, just predicting the next most likely word in a sentence. It's incredibly sophisticated mimicry, for sure. They are amazingly fluent, but deep down, they're kind of hollow. This image here just illustrates the core issue perfectly. LLMs are trapped in what you could call a symbol prison. They can describe gravity with flawless prose, right? But they have zero internal concept of what it actually feels like to drop a glass. It's a perfect example of Moravec's paradox in action, this wild idea that for AI, the stuff that's hard for us, like super advanced math, is easy. But the stuff that's a piece of cake for us, like the basic common sense of a toddler, is unbelievably difficult for them. So you can basically see three major cracks starting to appear in this whole foundation. First off, we're literally running out of high-quality text on the internet to train these things. Second, the cost, both in energy and just plain old money, is becoming completely unsustainable. And third, and this is the big one, the most critical issue, is the hallucination problem. Think about this for a second. Even after pouring in trillions of parameters and billions of dollars, the best models still just make stuff up somewhere between 3 and 10% of the time. And this isn't some bug you can just patch with the next update. No, this is a fundamental limitation of an architecture that has absolutely no way to check its own beautiful, eloquent statements against, the real world.
Okay, so if just predicting the next word is a dead end, where do we go from here? What's next? Well, the answer seems to be a total paradigm shift. A revolution, really. One that moves AI away from just imitating reality to maybe, just maybe, understanding it. And the leading contender for this next generation is something called JEPA. Now, instead of just predicting words, JEPA learns to build an abstract mental map of the world. It's like the difference between memorizing all the lines in a script versus actually understanding the plot of the play. It learns these core concepts, like object permanence, cause and effect, basically the fundamental rules of reality. So let's just boil it down. The entire function of today's massive, expensive LLMs, it all comes down to this one simple question. That's it. It's a really high-tech, incredibly sophisticated form of statistical guessing.
A world model, on the other hand, asks a completely different and way more profound question. See, this isn't about imitation anymore. It's about prediction, planning. It's about genuine competence. It's the difference between an AI that can describe how to ride a bike and one that can actually get on, balance, and start pedaling in a simulated world. Huge difference.
And this table here really lays out just how deep this shift goes. We're moving from systems that learn from text to ones that learn from actual sensory data. We're going from reactive token-by-token processing to predictive abstract representations, and maybe most importantly, we're shifting from an architecture that is just fundamentally prone to making things up to one that's self-correcting because it's constrained by the rules of its own internal world model.
Okay, so this all sounds great for the tech, but what does this massive leap actually mean for us? Because this isn't just about building a fancier chatbot, this is about fundamentally changing the entire nature of human work and even creativity.
And the scale of this transition is, well, it's enormous. Some studies are suggesting that around 80% of the entire workforce will see their jobs impacted in some way. But, and this is key, impacted does not mean replaced. It means our roles are about to evolve. We're about to get a promotion, in a sense, moving up the cognitive stack.
You see, we're moving away from being operators, the people who actually do all the tasks, and we're becoming orchestrators of these incredibly intelligent systems. Our new job? It's to set the big picture goals, to supervise what the AI is doing, and to provide the things only a human can: judgment, ethics, and real-world context. Basically, we stop doing the grunt work and start directing the work. I love this metaphor because it's such a powerful way to frame this whole shift. For years, we've been trying to build smarter and smarter dictionaries, systems that are absolute masters of all existing human knowledge. But now we're on the verge of building digital scientists, AIs that can actually form a hypothesis, run a simulation inside their own world model, and maybe, just maybe, discover genuinely new knowledge about the world. So what does this mean for ChatGPT and all the others? Are they just going to disappear? Probably not. The most likely future is a hybrid one. The fluent, easy-to-talk-to language models we use today, they'll become the skin. They'll be the friendly, conversational interface for a much deeper, much more powerful world-modeled brain that's doing all the heavy lifting and the real reasoning underneath.
So what we're witnessing here is a truly fundamental transition in AI. We're moving away from these incredibly fluent mimics and towards systems that can genuinely reason. This shift from predicting tokens to modeling truth, it isn't science fiction. It's happening right now. And really, the only question left to ask is, are we ready to guide it?